Hey, just thought I'd give you a quick talk through of this example problem. I think I have it all worked out clearly, but sometimes you need to hear it as well. So imagine a hot piece of iron, specific heat 4.0452 joules per gram degree Celsius is at 200 degrees. It's added to 100 grams of water, specific heat 4.18 joules per gram degree Celsius at 20 degrees. The final temperature of both the water and the iron is 29.22 degrees Celsius. What is the mass of the iron? Everything dealing with water's in red, or I'm sorry, iron is red, water's blue. This is purple because it's for both of them, and red and blue make purple. We start by using the formula Q equals mc delta T for the water. And what we're going to do is use the mass of the water from the problem times the specific heat of the water from the problem, figure out the change in temperature of the water from the problem using the final minus the initial, 29.22 minus 20, that's 9.22 degrees, times 4.18 joules per gram degree Celsius, times 100 grams. That gives you the energy gained by the water as 3,853.96 joules. Now, based on the notes from the previous slide, you'll see that the energy of the iron, the Q of the iron, is equal to negative Q of the water. The energy lost by the iron was gained by the water, so the signs are opposite. So water gained 3,853.96 joules, iron lost the same amount. Using that value in the formula for Q equals mc delta T for iron, we now know the value of Q right here. We're looking for the mass of the iron. We know the specific heat of the iron from the problem. We know the final minus initial temperature. When we do the subtraction, the change in temperature is negative 170.78, times the specific heat times the mass equals the Q value, the energy. If I simplify this, multiply these two numbers, the Q is equal to the mass times negative 77.19 joules per gram, degrees Celsius canceled out. Divide both sides by the negative 77.19, and I end up with the mass of iron being 49.93 grams. This is the same method you will use in the lab today when you're trying to figure out not the mass of X and Y, but their specific heats. So you will know the mass of water because you'll choose it. You know the specific heat of water. You're choosing the starting temperature. You will figure out how much energy is gained by the water from substance X and substance Y. Once you calculate that, you know how much X or Y lost. You'll know their masses. You'll know the temperature changes. You're solving for the specific heat. Let me know if you need help with any of the calculations. I'm online throughout the day.